Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3. This is paper 3-1 for October-November 2023 for questions 1 to 6. Question 1, find the exact coordinates of the points on the curve y is equal to x squared over 1 minus 3x at which the gradient of the tangent is equal to 8. Now, we know that gradient on any curve is always different at every point, but gradient on a straight line is always equal. The gradient on a straight line between two coordinates is always constant. So at the point of intersection, the tangent and the curve have the same gradient. So if this is the curve, this is my tangent. Of course, sometimes they also talk about the normal, which is the one that is perpendicular to the tangent. So at the point of intersection, this P here, the gradient is the same. So gradient of the tangent, differentiation is the process of finding gradient of the curve. So gradient of the tangent is equal to that of the curve at the point of intersection, which is going to be equal to dy dx. Okay. Now, since this one is a quotient, I can use the quotient rule while we're differentiating this. So I will let my u to be equal to, the one in the numerator is the u and then the v down. So u is going to be equal to x squared. Then du dx is going to be equal to 2x. And then v is going to be equal to 1 minus 3x. So meaning dv dx is going to be equal to a negative 3. So using the quotient rule, which states that if you have y which is equal to u is a function of x over v, which is a function of x, then dy dx is equal to v du dx minus u dv dx, then divide by v squared. This one is given in the list of formulae. Okay, so our dy dx here is going to be equal to v is 1 minus 3x, then du dx, that is 2x, then minus u, which is x squared, times dv dx, which is negative 3, then we divide by v squared, so 1 minus 3 of x, then squared. Then after this one, we shall equate it to 8, okay? Because the gradient of the tangent is equal to that dy dx. Now, simplifying this, we can cross multiply. Here, we shall have 2x, then minus 6x squared, then plus 3x squared. This one will be equal to 8 into, when you square this one, it will be 1 minus 6x, then plus 9x squared. So we can open the brackets fully, and we have, of course, this one here is going to come to negative 3x squared. So 2x minus 3x squared. This one will be equal to 8 minus 48 of x, then plus 72 of x squared. I can take everything this side to form a quadratic. So 72 plus the 3, that one will give us 75. So we shall get 75x squared. Then this is negative 48 minus 2x, that will give us minus 50 of x, and then plus 8. So that one is equal to 0. Now I can get my calculator to factorize this very fast. Mod, then we go to equation, which is 5, then 3, which is quadratic. I put 75, then negative 50, then 8. So this one gives us 2 over 5, and then 4 over 15. I'm going to skip some space, and then I write those figures, 4 over 15, and then 2 over 5. You are supposed to show the examiner that you solved the equation, okay? In order to cheat the examiner, cross multiply here, give us the factor from which these roots come. So this 15 multiplying with the x will give us 15x, and then bring this 4 here, it will become a minus, so minus 4. The same thing we do here, times, you don't write something like this, that x then minus 2 over 5 then is equal to 0. No, don't write that. Okay, we are going to have 5 of x, then bring the 2 here. It will give us that minus 2, which is equal to 0. Now they said that we find exact coordinates of the points. So meaning the point is not 1, okay? So for each of the x values that we have gotten, we are going to substitute in here to get the y coordinates, okay? So for x, which is equal to 4 over 15, for x, which is equal to 4 over 15, then what is y? Y is going to be, it is x squared, then we divide by 1 minus 3 of x, okay? We can put that in the calculator and we get an answer. How about for x, which is equal to 2 over 5? What is the y coordinate? So this will also be 2 over 5, then squared, out of 1 minus 3, then 2 over 5. So let's put this in the calculator. We see the y coordinates. Now we have 4 out of 15. Then we square that. Then we go down 1 minus 3 into 4 out of 15. Then altogether, this one gives us 16 over 45. 16 out of 45. Then how about when we put 2 over 5? So I'll come here, wherever there is 4 over 15, I'll put 2 over 5. Even up here, 2 over 5. So go up, so change that. So it gives us negative 4 over 5. Negative 4 over 5. Now smartly, I can write my coordinates as 4 over 15 and 16 out of 45. That is one coordinate. And then the other coordinate is the other points of the coordinate of the other coordinates of the point are 2 over 5 and then negative 4 over 5. So these are our answers. Question 2. On an Argand diagram, shade the region whose points represent complex numbers z satisfying the inequalities, these ones here. If you have been following me, I've always said that if you have the modular signs on both sides of the equation, that one represents the perpendicular bisector, okay, of the line joining the centers. So what are the centers? I can split this and then I create a negative here. So we shall have 0. Then this one will be plus 2i. It should not change the meaning because when you open here, you get this one here. Okay, since we don't have any real value in here, it is therefore going to be 0 here. Okay, and then this other one here, we are having z, then put a minus. This positive 2 now will become a negative, and then the negative I will now become a positive 1. Okay, so the center that we are getting here is 0, 2. And then the center we are getting here, okay, the center here we are getting is negative 2, then 1 as the coefficient of I. So here we draw a perpendicular bisector. Perpendicular bisector. We look at those points which are equidistant from the 2 points. That has to be the line which is in the middle. All the points on this line here are equidistant, same distance from this other one here, like that. Okay, so a perpendicular bisector of a line joining the centers, okay, joining points 0, 2 and negative 2, 1. Okay, then this other one here, I will also create a negative, the argument of z, then minus. So this one represents a half line. We need to know where this half line starts from. Okay, so z, since there is one here, this one, when it comes inside here, it will be a negative now, then plus 0i, because we don't see any complex, or I mean imaginary part. So then less than or equal to pi over 4. So meaning here we are going to draw a half line half line from -1, 0, okay, at an angle of pi over 4 or 45 degrees to the horizontal, okay, to the horizontal. Now let's do our sketch. I'm going to draw the axes here, and to be so perfect, you can even put your ruler and then you add on the labelings, the marks. So I can bring my ruler here, and then I can put those points properly. So like that, you label your axes and then you mark them. This is a sketch. You don't need to be so perfect, but to produce neat work, you can use your rulers and then you measure, and then you be jotting where a centimeter is, just like that. Okay, so we need to plot the centers 0, 2. 0, 2 is here. Then the other one is -1, -2, then 1, probably it is here. Okay, so this line that is joining these 2 points, we need a perpendicular bisector, and you know a perpendicular bisector passes through the midpoint. Okay, it passes through the midpoint. Now let's look at the gradient of this line here. This is 1 unit, these are 2 units. Okay, now for perpendicular lines, m1, m2 is equal to -1, right? So I can have my m2, that is the one for the perpendicular bisector. I can have my m2, which is going to be equal to -1, then out of a half, because the gradient of this one is a half, 1 unit here and then 2 units. Okay, so which is going to be equal to -2. So what is the midpoint of these 2 points? So 0 plus -2, that is -2, divided by 2, -1. So I have -1. And then 2 plus 1, that is 3, divided by 2, that is 1.5. So -1 and 1.5. -1 and 1.5, probably there. So I'm going to let this be my point where the line is going to pass through. That is the midpoint. Okay, then I'm supposed to move, since this is -2, this is a line that comes like this. Okay, so -2, I'll take it as 2 units up, then 1 unit down. Okay, so I'm going to go, this is the change in y, and then this is the change in x, right? So I will go, the change in x is 1 unit, so go 1 unit, okay, then 2 units. This is 1.5 plus 2, it will be 3.5. So I'll have something like this in the middle here. Okay, I'll have something like this. I just need 1 more point. I don't need very many, so that's enough. Then I can draw a line through those 2 points there. So let's draw that line. You get your ruler, then you connect these ones here. Draw a line through. So like that, that is our perpendicular bisector. Now the next one is the half line. So half line is -1, 0. -1, 0. So it is here. This is where it is starting from. And then we can measure 45. Of course, it has to pass through this point here. Okay, it has to pass through that point, because if we have a square and then all the angles are 90, so an angle that passes through the diagonal, this angle becomes a 45. Okay, so meaning that what we are going to have here, I'm going to draw the half line. It must start from here. Don't make it protrude through. Okay, it shouldn't exceed here, so it passes through that, like that. So meaning all the points that are in this region are less than or equal to pi over 4, the angle they make with this horizontal. Okay, so that is what we are having. Now to shade the region, it has to be look at this one here. The points that are on this circumference, I mean on this line here called the perpendicular bisector, they are equidistant from these points here. But now look at where the sign is pointing. Okay, 0, -2, I mean 0, 2. So this sign here is pointing this way. In other words, the point that is here, okay, its distance from this center here must be less than its distance from this other center here. 0, 2 is for this one here, okay? So its distance must be less than its distance from this point here, okay? So now, this simply means that a point that is in this region here, this way, is in the wanted region. A point that is here, a point that is here, okay, is going to be its distance. Let me actually just put it here. The point that is here, its distance from this point here, the 0, 2, is actually bigger than its distance from this point here, -2. And yet this distance here must be bigger than this one. Check where the centers are. In other words, to simplify your work, just look at the inequality sign. Where does it point? The inequality sign is like this. It is pointing to this one here. So if it is pointing this way, where is 0, 2? Our 0, 2 is here. So you go to that region. As simple as that. Now, then the points we are supposed to pick must also be in this region from 0 to pi/4. Okay, they should not exceed the half line. They should be within that. So therefore, we are going to shade from here, also here, like this, all of this. So we shade everything here. Just use this kind of shading. So it continues to go just like that. The line continues, okay? So all the points that are in this region, they are nearer to this point, okay, compared to this other point. That is one. Number two, their angle, the angle they form from the horizontal is not, let's say if I pick a point here, is not above 45. So the 45 is here. You see that? So that is what we are going to have there. I can even add on something like this, and then I put this is pi/4. So that is going to be our diagram. Question 3 is coming from logarithms. The variables x and y are related by the equation y is equal to ab to the power of x, where a and b are constants. The diagram shows the result of plotting natural log of y against x for two pairs of values x and y. The coordinates of these points are 1, 3.7, 2.2, 6.46. Now, before you start such questions, always look at what they have put on the vertical axis and on the horizontal axis. Okay, so we have natural log of y against against x. So meaning the coordinate here is x, but this one is natural log of y. It is not y, it is natural log of y. Even this one is x, then this is natural log of y. Okay, so we can introduce logarithms and then we reduce this one to a linear form. So we can have natural log of y, which is equal to the natural log of ab to the power of x. Okay, now since this is multiplication of the powers, this one comes from addition of logarithms to the same base. So we shall have natural log of a, then plus the natural log of b to the power of x. Again, this one can drop down using the rules of indices, rules of logarithms. So we shall have natural log of y, which is equal to natural log of b. Okay, natural log of b, and then that is the coefficient of the x. Okay, and then plus the natural log of a. So this one is in the linear form. Y is equal to mx plus c, where natural log of b is the gradient, and then c is there, then that C is going to be the y-intercept. Okay, since we are even given a graph, I can connect these 2 points like this. I draw a line all through them. Okay, when I draw a line through them, this line will cut this natural log of y-axis. Then I can get the y-intercept here. Okay, and that one will be the value for natural log of a. You see that? So I can begin from there, and I say that natural log of a is going to be equal to, that is 1.4. So what will be a? A will be equal to e to the power of 1.4. So what will be our a? E to the power of 1.4. This one will give us 4.055, and they never told us to give our answers maybe to 3 significant figures or what. So I'm going to write it to 3 significant figures, 4.06. 4.06, 3 significant figures. That is that. Then the gradient is this one here. How do we get the gradient? We get change in the vertical over change in the horizontal. So we shall have 6.46 minus 3.7. We divide by 2.2 minus 1. Then this one will be equivalent to natural log of b. Okay, so what is this one simplified? 6.46 minus 3.7. We divide by 2.2 minus 1, because that is 1.2. So that is 23 over 10, or 2.3. Okay, so meaning natural log of b is equivalent to 2.3. So to get b from here, it will be e, then to the power of 2.3. Shift, then e, then power the answer. So that will be 9.97 to 3 significant figures. 9.97 to 3 significant figures. So that is that. Question 4. The complex number u is defined. Question 4. The complex number u is defined by u is equal to 3 plus 2i over a minus 5i, where a is real. And then they are saying that express u in the Cartesian form, x plus iy, where x and y are in terms of a. So what we are going to do is to rationalize the denominator. Okay, rationalize. Some people say realize. Okay, the denominator. What do? We multiply the numerator and the denominator by the conjugate of the denominator. So what do I mean? This is u is going to be equal to 3, then plus 2i. Then we have a minus 5i. So the conjugate of this one, we just get the sign of this one, and then we change it. So it will be a plus 5i. Then up here, we shall have a plus 5i, the same. Okay, it's like we have done nothing, because this one can easily cancel with that. Okay, now we open the brackets. 3 times a, that is 3a. 3 times 5i, that will be 15i. Then 2i times a, that will be 2ai. And then minus 10, because you know that I squared is equal to negative 1. So we shall get 10i squared. Okay, now down here, we are going to have a times a, that is a squared. A times 5i, we are going to have plus 5ai, then minus 5ai. This is actually the difference of 2 squares. You can just get a squared, then minus, then 5i squared. Okay, so then we shall have minus 25i squared. But you know that I squared is negative 1. Okay, so that means this one is going to become a plus. Okay, so I can just put here a plus. So meaning we can simplify this and say 3a minus 10, then plus, this is 15 plus 2a. These ones have gotten I on them. Then divide by a squared plus 25. So therefore our u is going to be equal to, if I separate the real from the imaginary, we shall get 3a minus 10 divided by a squared plus 25, then plus 15 plus 2a out of a squared plus 25 of I. So this is our answer. The imaginary part and the real parts are in terms of a. Then next part B, given that the argument of u is pi over 4, find the value of a. Now that means this one is found in the first quadrant, okay? Because the angle here is positive. So we need the y value, or what we call the imaginary here. It is that 15 plus 2a out of a squared plus 25. This is pi over 4. Then the x is 3a minus 10, or the real, over a squared plus 25. Okay? So this is the imaginary of z. This is the real of z. Now we need to find that angle. So since this is a right angled triangle, we have the opposite and then the adjacent. Okay? So that will be tan, using SOHCAHTOA. So tan pi over 4 is equal to, the imaginary part is 15 plus 2a, then divide by a squared plus 25. Then we shall divide by the real part, which is 3a minus 10 out of a squared plus 25. So this one will somersault, and we shall see that this one cancels with that. So this one, first of all, tan of pi over 4 is a 1. So we shall get 15 plus 2a, then out of 3a minus 10. When we cross multiply, this will be 3a minus 10, which is equal to 15 plus 2a. So bring this one here, take this one this side. Okay? So when we do so, we shall have 3a minus the 2a, which is equal to 15, then plus 10. So our a is therefore going to be equal to 25. Question 5, part A. Given that sine of x plus pi over 6 minus sine of x minus pi over 6 is equal to cos of x plus pi over 3 minus cos of x minus pi over 3, find the exact value of the tan of x. Now here we are going to use the double angle expansion of sine and cosine. Okay? So let's look at the left side. Sine of a plus b, okay, is given by, in the list of formulae, they give it to you. So sine, I can say, of a plus b. Let me also put a minus here. This one is going to be sine of a cos of b, then plus or minus sine of a, cosine of a, then sine of b. Then for cosine, cos of a plus or minus b. This one is going to be cos a, cos b, then minus or plus. Because if you have a plus here, then here you will have a minus. Then if you have a minus here, this way you will have a plus. So that's why we are putting them like that. Even in the list of formulae, they appear like that. So here we shall have sine of a, sine b. Now we apply the left side. The left-hand side is going to be equal to sine of x, then cosine of pi over 6. Then I'm dealing with this first, okay? Plus cosine of x sine of pi over 6. Then after that, now subtract. Now we expand this one. So it is going to be sine of x cosine of pi over 6. Then subtract cos of x sine of pi over 6. Now, when I open the brackets, I can see that this one goes with this. You see that? Because this one is positive, this one will be a minus. And then this one here, there is a minus here, and then a minus, so it is going to become 2 times. Okay? So I can write 2 cos x sine pi over 6. This is 2 cosine of x, then times sine pi over 6 is actually a half. That means this one gives us a cosine. Then let's go to the right side. The right side is given as cosine. So we shall have cos x, then cos pi over 3, then plus, because this one is a minus. No. This, I'm supposed to put a minus because this one is a plus, right? So minus sine of x sine of pi over 3. After that, then there is a minus there. We have now cosine of x cos of pi over 3, then plus sine of x sine pi over 3. We can actually expand this using what we call the factor formula in trigonometry, but it is not in the Cambridge books, okay? Though you can look out for it. It can actually simplify this. Sine minus sine, it is 2 cos sine, okay? Look out for it. There is a number I will do in actually 3-2, October, November 2023, paper 3-2. I'll do that number. I think it is question 9, somewhere there. So I'll show it to you. Now, here we are going to have cosine of pi over 3 is a half. So I can have a half cos of x. But also, when I open, this one will cancel with this one here. So I'm not going to disturb myself here. Then this is minus of this, then minus of this one. So it is going to be minus 2, right? So we shall remain with a minus 2 sine x sine pi over 3. And this is minus 2 sine of x. Then we multiply by root 3 over 2. Because sine of 6 is root 3 over 2. And these 2 can cancel. That means what we are remaining with here, it is going to be negative root of 3 sine of x. Now, this simply implies that on the left we have a cosine of x, and then on the right we have a negative root of 3 sine of x. And they want us to find the exact value of tan. How can we get a tan from here? We divide all through by the cosine, because tan is sine over cosine. So we shall have a 1 here, which will be equal to negative root of 3. Then here you will have a tan x, sine over cosine, okay? So meaning the tan of x will be equal to negative 1 over root of 3. Okay, that will be the exact value. Or we can write it as negative root of 3 over 3. It is also the same. Part B, hence find the exact roots of this equation. Hence, begin from where you have stopped. So it is the same thing that we are having here, but we have already simplified it to tan x, which is equal to negative 1 over root of 3. So meaning x is going to be equal to the arctan of negative 1 over root of 3. When you put this one in the calculator, it is going to give you a negative answer. It's negative 30 degrees or pi over 6. But remember, the domain given here it is from 0 to 2 pi. So I'm going to consider quadrants where tan is negative. A, S, T, C. Tan is negative here in the fourth quadrant and also here. So if I have my angle here as x, then this one is also x, and then x here. So this is 0, then pi over 2, then pi. When we move anti-clockwise, the angles are positives, okay? Then when we come back here, it is 2 pi. So that is that. When you move anti-clockwise, positive, then when you move clockwise, they are negatives. So do you see that when you move clockwise, this angle that you are getting here, the 30 degrees, you fall into the quadrant of cosine where tan is negative, You see that? So what I always say is that ignore the negative, and then you first get the arctan of 1 over root 3, which gives you that pi over what? 6. Now, when you are writing here, you just say, from here up to here, that one is get the whole thing from here up to here, which is pi, then minus this one here. So to get an angle in the second quadrant, we write pi minus that acute angle. Okay, of course, here it is pi plus the x, and then when you reach here, it is 2 pi minus the x. You are moving like this up to there. You see that? Okay, now this one is going to be pi minus that pi over 6, and then the other one is going to be 2 pi minus that pi over 6. So meaning x is going to be 6 minus 1, that will be a 5 pi over 6, and then 12 minus 1 will give us 11 out of 6. So this will be 11 out of 6 of pi. Those will be our answers here. Question 6 is coming from parametric differentiation. So they are saying the parametric equations of the curve are x is this, then y is this. And then they want us to obtain a simplified expression for dy dx in terms of t. So what are we therefore going to do? We are going to differentiate x with respect to t. So this one, remember, is the same as t power half, okay? So when we are differentiating, we are going to drop the power, and then we reduce it by 1. So we shall have negative a half, then t power a half minus 1, you get negative a half. Of course, when you differentiate a constant, it disappears, right? Then, when we come to y, you should know that when you differentiate natural log of a function, you just get the function, you differentiate it, then you divide by that same function, okay? So it's the same thing we are going to do here. dy dt is going to be, differentiate the t, you will get a 1. Then divide by that function t, so it is 1 over t. Now for us to get dy dx, this one is going to be equal to dy dt, then times dt dx. That is using chain rule, because this one can cancel with this, and then you remain with dy dx. You see that? Now, we are going to get dy dt, which is 1 over t, and then times dt dx is going to be 1 over this one here, okay? So it is 1 over, I can take this one down here for the power to become a positive. So it will be negative a half, then t power a half, okay? So I'll get the reciprocal of that one. I'll say times, this one now will go up to t power a half, okay? I've multiplied by the reciprocal of this one. So we shall have t power this a half, then you divide by negative 1. Of course, we don't write the negative 1 in the denominator. So that's why I've written it here, okay? So that is that there. But now we can simplify it because using indices, this t power half, we can subtract a 1, this one which is down. You see that? Then we shall get t power negative what? A half. Again, this one can go down, and we have 1 over t power a half. So I'm going to write my answer here as negative t, negative 2 out of root of t. That is that. Then next part B, hence begin from where you have stopped. In other words, find a way of using what you have gotten to solve this. So hence find the exact coordinates of the point on the curve at which the gradient of the normal is negative 2. Just like I showed you before, if you have a curve here, then a line that intersects the curve at only one point is what we call the tangent. Okay, this is the tangent. Then a line which is perpendicular to the tangent is what we call the normal. Okay, if this is the curve here. So, and dy dx represents the gradient of the tangent. So gradient of the normal, since these two are perpendicular, it is going to be gradient of normal is going to be equal to negative 1 out of gradient of the tangent, which gradient of the tangent we have gotten as negative 2 over root of t. Oh, by the way, excuse me, up here, the power here is a positive. So this one here is supposed to be a positive there. So there is no negative here. Okay. Let me remove every negative that I had put. Kindly pardon me here. So we have 2 over root of 2. Then when we come to this one here, I will also remove this negative here. So that means this one will be root of t divided by 2. Okay? A negative. Now, this negative root of t over 2, we shall equate it to this negative 2 that is given here. Then we cross multiply. Of course, root of t is going to be equal to 4. I've queued the negatives, okay? And then from there, we can square both sides. So that means t is going to be equal to 16. If t is equal to 16, they asked for the exact coordinates. So we need to find the x coordinate that corresponds to this t being 16 and also the y coordinate, okay? So x is going to be equivalent to, it was given as root of t. So root of 16, then plus 3. Isn't it that? Yes, root of t plus 3. So this will be root of 16. That one will be 4 plus 3, then 7. So x here is 7. And then what will be y? Y is natural log of t, which is 16. So meaning the exact coordinates of the point are 7 and natural log of 16. Okay, so that is that. So this has been it for this first part of this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next video.